Lesson 10, a continuation of Lesson 9, which was also representing naming and evaluating functions, with the same instructional outcomes as Lesson 9, to understand that a function from one set to another set assigns each element of the domain to exactly one element of the range, and then to evaluate functions for their inputs and domain. So there'll be three exercises that we'll take a look at here. That continues to follow through Lesson 9, what we talked about: domain, range, function, and function notation. So in exercise number 1, we want to reemphasize those definitions to where domain is known as the set of x's and the range is the set of y's. So if we look here, this says x equals, so here's our domain. Our domain is limited to 0, 1, 2, 3, 4, and then 5. Now they tell us to complete the following table and use the definition of the function. So here we are, an x maps to each y, where we assign this expression 2 to the x power. And so if we fill in that table and we solve each one at a time, whereas here is our x's and here's our x at the top. So if I said 2 to the 0 power, that would equal 1. 2 to the first power, that would equal 2. 2 squared, that would equal 4. And if we continue down the line, this would end up being an 8, then a 16, and then a 32. In the second part that follows up, they mention what does this particular piece mean. So if we were to say f of 0, it's basically stating this question: if x equals 0, then what is the corresponding y value? And so that's what they're asking. The answers are going to be the same, so we'll just kind of put a footnote on that if we said f of 0, then f of 0 is equal to 1, because that's if x is equal to 0, that's this case right here. Then what is the y value? We said that was that piece of information right there. So then if I continue on, if I said f of not 2 but 1, then we said that was equal to 2. If we said f of 2, that was equal to 4. Again, that's by plugging in this 2 right here and getting this particular answer here. And then it continues on down the line. F of 3 was equal to 8, f of 4 was equal to 16, and f of 5 was equal to 32. Now it follows up with what is the range. Now we only have a set domain. Our domain, again to reemphasize, lives only in between a 0, 1, 2, 3, 4, and then 5. So if that's the only pieces I'm considering, then when I write my range is going to be the answers that correspond, which is 1, 2, 4, 8, 16, and 32. If we look at exercise number 2 and kind of contrast the difference, notice in example number 2, they say this is a squaring function to where our x's map to x squared. So we'll just emphasize that. If we're given an x, we're going to map it to x squared. And so that's what we have to deal with. Notice the difference this time. They did not give me a single solitary list of x's that I have to deal with in this given piece. Initially they did. But they do ask here, what are these values? And so that's what we're working on, and that's what we're looking at in this given case. So if we see f of 0, what does that mean? That means we're going to take this 0 and we're going to plug it in and have 0 squared. And so f of 0 will end up equaling itself 0. So if I want to know f of 3, then that means I plug 3 in for x, and that means I have 3 squared. so that's going to equal 9. If I was to use my -2, so f of -2, that's going to map to -2 squared. And so be careful here. -2 times -2 is 4. It is very common for students to accidentally put a -4 because you're not using the parentheses. So I'll emphasize the necessity of using these parentheses if you're going to test this in the calculator. It is very important that you follow through with that given piece and so forth. So just to continue on, if we had f of -2.5, and so that's over here at -2.5, and we place that in, so -2.5, and we square that, that's going to equal 6.25. The f of 2/3, so if we take 2/3 and plug that into here and square it. Now again, a lot of students start to panic with this and they think, oh goodness, fractions, what do I do? But if you follow through and think about it, I can square both the 2 and the 3. So 2 squared over 3 squared, and that is just 4 over 9. So don't panic the moment you see a fraction. Think your way through it as to what makes logical sense in that given instance and case. And so we look at those and so forth. This case here with the a, if we were to say f of a, that would just equal a squared. And if we said f of 3 plus a, that would equal 3 plus a squared. I'm going to leave it as the 3 plus a and then square like that for the time being, and not multiply it out at this given time, and so forth. So they say, what is the range of this value? So this is what we're dealing with right here. This is our y values, or what's going to be our range. And so if we were to illustrate that with a graph, so if we drew a y-axis and an x-axis, and then we're going to represent x squared. X squared, as mentioned in previous lessons, is a parabolic curve, like so. And so if I wanted to talk about the range, remember, by definition, the range is the set of y's. Well, I mean, I have points that are infinitely many along this curve. And so the lowest y value that I can see on here is 0. And then it looks like the graph just continues to grow forever and ever in the y direction. It won't stop going up. It'll keep going. And so if that's the case, then we would say for our range, in two different ways of writing it, we would say a bracket around 0, because we're going to include 0, so it's starting there, and it's going to go all the way to infinity. Or as an alternate way you could state it is all real numbers. This is the symbol for all real numbers. It's kind of like a double R, such that x is greater than, or we should say, not say x, because again we're talking about ranges, such that y is greater than or equal to 0. And that would include all of those given pieces. Finally, in exercise number 3, they give us an equation. They want us to determine whether it is true or whether it's false using the function defined as this. So this is our x's and this is our y's, such that x is equal to, or x maps to 2 to the x power. Determine whether the equation 2 to the x is true or false for each of the given pieces. So if we plugged in this one, for example, they say is true, and the justification is if you plug 0 in here, to the 0 power is equal to 1, so it does match. If we were to take this one and say 2 to the first power, that's going to equal to 2. And so again, we see that this 1 here maps to this 2 here. And so we would say that that is T for true. If we were to look at the next one, 2 to the 4th power, or 2 squared I should say, is equal to 4. And so then again we go up here and match it up. The 2 maps to the 4, and so that is true. And as you continue to work your way down the given table, you're going to notice that each one of these is true. In fact, it is the same piece that we looked at earlier at the beginning. 0, 1, 2, 3, 4, 5. If we had 2 to the x power, is the 1, 2, 4, 8, 16, 32 from the opening exercise that we practiced in this particular lesson.